Problem 14 says let y equal ln of x. Show that dy dx equals 1 over x by solving the equation for y equals ln of x for x and then using implicit differentiation. Your final answer should be dy dx given as a function of x. So all of the steps to complete this problem are actually given in the instructions. So the first thing that we want to do is we want to start with the equation y equals ln of x. Then we were instructed to solve this equation for x. So we solve it by raising both sides over e. So e to the y equals x. So I'm going to write the steps down in pink. So now we've solved for x. Then it tells us to use implicit differentiation on this equation. So the derivative of e to the y is e to the y dy dx, and the derivative of x is 1. So this is our implicit differentiation step. Now we want to do algebra and solve this equation for dy dx. But we were told that our final answer should be as a function of x. So we need to now rewrite this as a function of x. So if we go back and kind of look at our previous work, well, we actually have an expression for e to the y, and we know that it equals x. So that means I can replace e to the y with x. So here we sub e to the y for x, since x equals e to the y. So once you're here, you're done, and we got the derivative as desired. So there are 3 other functions that you're responsible for knowing how to do these steps on. We could do it for the function y equals arc sine of x, y equals arc cosine of x, and y equals arc tan of x. So it's a very similar structure. You solve for x, use implicit differentiation, solve for dy dx, but on the substitution step, you can either, for substitution, you either use a triangle to find the desired, this triangle has an L in it. You either use a triangle to find the desired new trig function that you will create through this process, or you can use a Pythagorean identity can't spell today. You can use a Pythagorean identity to substitute algebraically. So make sure that when you're studying that you're going over and reviewing those proofs. And on the handout you were given of things you should be responsible for, these were the 4 proofs for derivatives that we said you should be responsible for the final exam.